In this lesson, we're looking at transformations that either stretch or compress vertically. And as we always do with transformations, the first thing we'll do is we will identify the parent graph. And in both of these that I have here, number 1 and number 2, our parent graph is a quadratic, and we identify that from that x squared. So that we know that our basic shape is going to be a quadratic equation, which is a parabola. And I'm going to put everything here on the same graph because I think it will make more sense when you see all of them together. So the first thing I want to do is to plot the parent graph, and we know that the parent graph for both of these is going to be x squared. So let's just plug in a few points. If x is 0, we know that y is 0. If x is 1, then y is going to be 1. And if x is negative 1, y is also 1. If x is 2, then y is going to be 4. And if x is negative 2, y is also going to be 4. So our basic shape looks something like this. So that is our parent. Now let's look and let's see in number 1 what that multiplication by 3 does. The multiplication by 3 we will find will actually stretch this parent graph. And what I mean by stretching is you can imagine that there's a couple of endpoints here at the top, and if you pull them upwards, as you might if you had a rubber band, when you stretch a rubber band it gets thinner. So the effect of stretching is going to leave this having the same shape, but it's going to have a thinner curve. So let's plot some points and see how that works. Let's say x here and f of x. So if x is 0, if we square 0 and then multiply that by 3, so our 0 point is still the same. If we substitute in a 1, let's say, for x, and square that and then multiply by 3, if we substitute in a negative 1, we're going to get the same result. We're going to get a positive 3. So our thinner graph is going to look something like this. It's going to have the same 0 point, but it's definitely going to be thinner. We are stretching, and by stretching mean we're pulling the tops, and that will make it a thinner curve. The second function, g of x, we're multiplying by a 1/3, and that's going to have the effect of compressing. So if you think of pushing down on those ends, what's going to happen is you'll have the same basic shape, but your curve is going to get wider. And let's map out a few points to see what we mean by that. So if we substitute in a 0, our 0 point's going to stay the same because 0 squared is 0 times 1/3 is 0. Let's say that we put a 1 in. So 1 squared is 1 times 1/3 is 1/3. And if we put a negative 1 in there, we're going to get the same result. We'll also get a 1/3. Let's say we put, let's put a 2 in there. And so 2 squared is 4, which I'm going to multiply by 1/3, so we get 4/3. And if I put a negative 2 in there, I'll get the same result. So we're going to have to do a little estimating on our points here. We start out at 0, 0, same as we did before. We're going to go to x is equal to 1, and our y is going to be 1/3, so we're just going to have to estimate that. Okay, and then we're going to go to x is 2 and y is 4/3, which is 1 1/3, so we're out here. So our curve now is going to look like this. Okay, so stretching, imagine pulling a rubber band. Your curve is going to look like the parent curve but thinner. Compressing, so your final function is going to look like your parent curve, only you're pushing down on it from the top, so it's going to get wider.